Let's keep cranking through some more things. A kg of trash, depending on what it is, produces lots of carbon footprint as well. It's 200 grams CO2 equivalent if it's just garden waste, 700 grams if it's average trash contents that we expect, 9 kilograms of CO2 equivalent if it's aluminum and copper trash. So the average US citizen sends 570 kilograms to landfill or incineration each year and recycles just 290 kilograms. This causes around 400 kilograms of net CO2 emissions, CO2 equivalent, or 4% of a 10-ton lifestyle. Again, if you work out a 10-ton lifestyle, you can see how many things are going to keep adding up if you are not careful. 23 here is a reference that I forgot to make a superscript or just remove. Every time you don't recycle and trash things like aluminum cans or paper or whatever else, then you also force production of new virgin material, which adds to the carbon footprint as well overall. Looking at the annual footprint of the average UK homeowner sending waste to landfill rather than to recycling or composting, like the garden waste, for example. Look at these kilograms of CO2 equivalent. You have paper and cardboard, landfill emissions, and forcing unnecessary virgin production. So landfill is always a bad idea in terms of anaerobic restoration and methane production. Methane is 25 times as powerful as a greenhouse gas compared to CO2 when you compute the effects over the same period of time for a molecule of methane or a kilogram of methane. Numbers differ slightly, but nonetheless it's much more powerful than CO2. Kitchen and food waste mostly would end up in landfill emissions because the food production would happen anyways. Garden and plant waste, textiles, a lot of it is just forcing unnecessary virgin production. Very little ends up in landfills. Plastic, again, forcing new production is a big cost. Landfill emissions are smaller. It's not good news because it doesn't biodegrade so easily. Ferrous metal, non-ferrous metal, miscellaneous combustibles, glass, and other trash here. So that's what UK produces. If you look at the footprint per kilo of throwing stuff into landfills compared with recycling or composting it, in other words, this graph shows the difference that recycling makes. So recycling versus throwing stuff into the landfill. So paper and cardboard, again, new production versus landfill emissions, kitchen food waste, garden plant waste, other organic waste, wood, textiles, plastic, plastic film. So this is dense plastic, this is film plastic, ferrous metal, non-ferrous metal, and so on. So this is what the annual footprint of a UK homeowner is, and this is the savings you would have if you recycled instead of you would have if you recycled instead of dumping it into landfills. Okay, doing dishes, it's almost zero CO2 equivalent by hand in cold water, but this is considered not as hygienic because several 100% more bacteria are left behind when you do it this way. There are lots of stories about dirty sponges having microbes living on them that don't die even if you microwave the sponge, for example. And there is 540 grams of CO2 equivalent when you do it by hand, but use water sparingly and it's not too hot. So 770 grams of CO2 equivalent in a dishwasher at 55 degrees centigrade. 990 grams CO2 equivalent in a dishwasher at 65 degrees. So obviously people prefer hot water because it gives you a sense that things are getting cleaner, even though that's not necessarily always true. 8 kilograms of CO2 equivalent by hand with extravagant use of water. Running a dishwasher twice a week on the economy setting comes to 80 kilograms per year, equivalent to a 110-mile drive in an average. The main story here is hand washing versus dishwasher. Hygienically and in terms of these other details, dishwasher run fully every time is a better overall choice. Okay, that's what you have to remember. A roll of toilet paper, another complicated issue. Water versus paper. Cultural dependence, of course. You can see that in the amount of toilet paper used in the Western world versus Asia versus Africa and so on. But 450 grams of CO2 equivalent is generated when you use recycled toilet paper. Recycled paper that's used to make toilet paper. It jumps to 730 grams CO2 equivalent if it's virgin paper. If you have a typical North American wiping habits, that comes out at 75 kilograms CO2 equivalent per year, or 3/4% of the 10-ton lifestyle. This is not an easy subject to discuss. One can argue, like the author does, about whether we are paying too much attention to the bum in terms of cleaning it, because North Americans use enormous amount of toilet paper, and compared to Europeans even. Are they more hygienic? Are they being more hygienic? Not necessarily. It just turns out that cultural memes and what you learn as you grow up about how clean things have to be can make a difference. But you can choose your own. There are also arguments to be made about toilet paper versus water, and when you use water to clean the behind, you can introduce E. coli into groundwater, which can be an issue when there is not enough clean groundwater available, or people defecating in the open as opposed to having wastewater treatment and sanitation systems can be an issue. So it's complicated, but we narrowly focus here only on the toilet paper. The big issue is, of course, driving. If you take driving a mile, it depends on the kind of car, how many people travel, what kind of fuel you're using, and so on. You get 350 grams CO2 equivalent in a Fiat 500 doing a steady 60 miles per hour. Fuel efficiency does depend on how fast or how slow you drive. 850 grams CO2 equivalent in an average US car, achieving a typical 22.4 miles per gallon. Fuel efficiency standards have gone up, but Obama set one standard and Trump rolled it back, and now Biden has again set it higher. So in general, the size of the car and the fuel efficiency are obviously important. 2500 grams CO2 equivalent in a Mercedes-Benz SUV, new but not looked after, doing 90 miles an hour. So driving a vehicle 10,000 miles would use between 35 and 250% of the 10-ton lifestyle, depending on what you drive and how you drive it. Of course, as we said before, driving is a big part of life now pretty much everywhere. Even in the developing world, the top 10% of the income earners, or maybe even higher, are owning cars and driving quite a bit for vacations, for work, for just status symbol and so on and so forth, and people even collect cars. But your diet can make a big difference, and your driving habits can make a big difference. Just as we saw a minibus and a train being fully loaded and overcrowded in India and countries like India, a car can be driven full. So if you drive a car full at a reasonable speed, especially if it's a hybrid or electric vehicle, then you can do better than a train. But as we said before, unless the electric vehicle is getting its power from a clean renewable energy source, you just shift it from emissions from the vehicle versus emissions at the power plant. So you don't necessarily gain, except that the internal combustion engines are much less efficient in converting fossil fuel into driving the motor compared to electric cars. So once electricity is given, the electric electric cars are still much more efficient than internal combustion engines, which are directly burning fossil fuels. So some little percentage of savings would happen anyways. But it's not just what model you drive that matters. Here are 10 good ways to reduce the carbon footprint of your car use. Use the train, bus, or bike if traveling alone. Typical savings of 40 to 98% depending on what alternate mode you would have taken otherwise. Put more people in the car. This could make it better than train travel, provided that the others were otherwise going to drive separately. Typical savings could be 50 to 80% in terms of carbon emissions. Join a car sharing scheme. Drive a small efficient car. Typical savings here could be 50% compared with the average car, but again it depends on what you can afford. Look after your car so that it will do 200,000 miles in its lifetime and it runs as efficiently as it can. Even inflating tires and checking the engine, cleaning the engine, etc. matter. Here typical savings could be 30% compared to the average. Accelerate and decelerate gently. Driving habits do matter, so sudden acceleration and deceleration, loss of energy in braking and accelerating, fuel efficiency loss during acceleration, etc. matter. Avoid braking where possible. Hybrid cars and electric cars do have regenerative braking where electricity can be reproduced using that loss during braking. Typical savings up to 20% in urban conditions. In highways, if you are driving at steady speeds and not braking, obviously this saving would be lower. Drive at 60 miles per hour on highways and freeways. Typical savings 10% compared with 70 miles an hour. So fuel efficiency goes down as you drive at higher speeds. Keep windows up when driving fast and the air conditioning off. Typical savings 2%. So air conditioning is a big consumer of energy from the engines as well. Keep the tires at the right pressure. Typical saving 1%, but also safety wise it's better. Avoid rush hour if you can, and drive safely, of course. And a simple back of the envelope calculation has been done by the author on how to save carbon without losing money when you drive. If you drive at 70 miles an hour versus 60 miles per hour, and if you think that time is money, and if your time per hour is $24, then miles per gallon of efficiency is, let's say, 33 miles or 45 miles, depending on at what speed you are driving. So the fuel efficiency drops from 45 miles per gallon to 33 miles per gallon when you go to 70 miles an hour of driving speed. Carbon footprint of a 70-mile round-trip commute is 21 kgs if you drive at 70 miles per hour, and 16 kilograms CO2 equivalent if you're driving at 60 miles an hour. So there is a significant saving each day if you're commuting this much each day. Time cost of the 70-mile commute, assuming this price here is $24 here and it's $29, so you're going to pay, let's say, 5 miles more for this commute you are doing every day. Cost of gasoline here will take some of that to $6 based on this fuel efficiency loss, and here you'd pay $4 for that commute. So the total cost here is $30 and total cost here is $33. So even though time is money, you are not really saving that much, or you have to think how much you are willing to pay for reducing your carbon footprint by driving at a slower speed and reducing carbon emissions. Okay, so all sorts of considerations can go into it. The life cycle analysis, of course, should include the car manufacturing, fossil fuel, transportation, mining, production, treatments, and most of the emissions come at the tailpipe, but there is a lot of emission behind a car as well before you get it, and after you get it, the money you have to spend to maintain it over time, and so on and so forth. Okay, again, to just to repeat myself, these are just to give you awareness and not to tell you what to do, but to give you a sense of ownership of your actions and your carbon footprint.